Welcome to Pomodoro Joe for Tuesday, March 21st, 2023. Today we're looking at LeetCode problem 2348, number of zero-filled subarrays. This is a medium problem. Given an integer array nums, return the number of subarrays filled with 0. A subarray is a contiguous non-empty sequence of elements within an array. And they have a couple examples here. So you've got 1, 3, 0, 0, 2, 0, 0, 4. So if we were to find the subarrays, 1 is just the 0 by itself, so that's 1. And this 0 by itself is 2, so that's 1, 2. And then the two of them together is 3. And the same thing over here. So that would be 4, 5, and 6. Let's see if that's right. And they return 6. That's right. How about this one? We've got 1, 2, 3, and then these two make 4. And these two make 5, and then these 3 make 6, and then these two we've already determined are 3, so it's 1, 2, and the 2 together is 3. So that's 9 in total. Yep. Okay, so we'll put 25 minutes on the Pomodoro timer and get started. All right, with most of my solutions that return integers, I like to start with some result, and that will be a 0. At the end, we will return our result. So how do we start in solving a problem like this? Well, I think the first thing I'd like to do is find all of the ranges of my zeros. So we'll just find the start index and the end index, and that will determine sort of the range of zeros, or the range of contiguous zeros. Once I find that, so for example, I would find these 3 zeros, it'd be index 0 and up through index 2. Once I find that, then I can find how many subarrays would fit inside of this range of zeros. So let's do that. So we'll have some group of subarrays. Okay, so I'll have some list of subarray ranges. And each range will have a current range, and each range will have a start index and an end index. So I'll put that here. Okay, now we'll just go through all of the numbers in our nums list, looking for these zeros. Okay, so the n is either a 0 or it's not. This number is 0 or it's some other number. If it is a 0, what do we do? Well, let's see. It kind of depends on if we've started our current range or not. So let's see. If our current range is empty, yeah, let's say. If our current range is the empty list, that means we haven't started a range yet. So we can say our current range will equal, let's see, what does this equal? Oh, I need the index of this number. So I can't just use n here. I'll need to have the index and the number. So I can get that by calling enumerate on this list of numbers. So now that I have both the index and the number, I can store, let's see, well, this range of zeros starts at this index and currently ends at this index. All right. Now, if the current range is not empty, well, then we already have some start range here, some start index. So our current range we can extend. So let's see, our current range at index 1 will be equal to I. Okay, so let's see. If our n is 0, if we haven't started a current range, we'll start it, and it starts and ends on this index. Otherwise, if n is 0 and we already have some current range, we'll just update the ending index here to be our current index. Okay, now if n is not 0, then let's see. If our current range is not the empty range, let's add it to our subarray ranges. And then we will need to reset our range. So our current range is now equal to the empty range. or an empty list. Okay, so this builds up all of these subarrays that we're looking for. So let's just print this out and see what we get. I guess there's one more range. When we get to the end here, if we have a current range, that's going to be part of our subarray because we didn't have this else block to add it to our subarray. So let's do this here. Once we're out of our for loop, we still might have a valid subarray. Okay, let's just run this. We won't have the right answer, but we can see whether or not we're finding the right subarrays here. So we have 2 to 3. Let's see, 0, 1, 2, 3. That works. And 5 to 6. So this is 4, 5, 6. Okay, seems to be working with that one. What about case 2 here? We have 1, 2, 3. So this goes from 0 to 2, 0, 1, 2. All right, 3, 4, 5. Excellent. So we're finding all of the ranges of zeros. Now within each one of these ranges, we have multiple subarrays. For example, these 3 zeros are actually 1 subarray of just 0, 2, 3 subarrays of just 0, 1 subarray of 2 here, and another subarray of 2 here, and then one more group of 3. So that subarray makes a total of 6 subarrays just for these 3 zeros. So that seems to be, let's see, if we only had 1 0, we would only have 1 subarray. If we have 2 zeros, we've got 1, 2, and then 3 subarrays. So that's the 1 original subarray plus 2 more. When we have 3 zeros, we've got the 1 original subarray plus 2 for the next 0 and the grouping, plus 3 more. So it looks like this is just adding 1, 2, 3. So that would be the sum of the range of this subarray, or subrange, I should say. Okay, so let's see if we did that. So for, let's see, so for every subarray range in our subarray ranges, it looks like our result will be increased by the sum of the range of the length of that subarray. Now that's confusing to even say. So let's try this. Let's say the length of our subarray, we'll call it the range length. So the range length is going to be, let's see, our subarray range at the end index, so that's going to be 1 minus the subarray range at the start index, which is 0, plus 1. So if they start and end on the same index, if we just had 1 0 by itself, this would be, say, index 1 to index 1. It's going to give us 0 if we just subtracted the 2. So we need to add the 1 element back in. Okay, and now we can say our result will be increased by the sum of, in this case we have to say the range of our range length. You could also go through and say, like, while range length is greater than 0, maybe we'll do that actually. Let's do that. No, let's do this. This is fine. Let's see if this works. Okay, this does not work. What am I missing here? Oh, this range will only go up to, but not including the end element here. So I need to add 1 to this range length. That seems to work. Let's see if this works. All right, and we do pass, but this is a terrible algorithm. We passed, but we only beat 13% for runtime and only 7% for memory. Let's see if we can fix this up a little bit. Well, one thing we can do here is this sum of range, blah, blah, blah. What if we change this to a while loop? So while the range length is greater than 0, our result will add in our range length, and then we'll have to decrement our range length. Okay, let's see if this gives us the right answer, first of all, and let's also see if we can get a better runtime. Okay, it still seems to work. Let's see what our runtime gives us. All right, a little bit better, 18% for runtime and 7% for memory, a little bit better. Okay, I was kind of tricking you. This isn't a great way to solve this problem, but it's a good way to think about approaching the problem. Now, when you get to this point, you can say, well, do I really need to keep all these subarray ranges and go through them again? So we already know that every time we get to a subarray or a subarray range, we don't need to add it to this subarray range array and calculate it later. We could just do this calculation as soon as we find that current range. So let's skip adding this range to some range array here. Let's get rid of this. And instead of putting it in this range, we'll just calculate. We've already got this calculation right here. So we'll go ahead and calculate our new score. And then reset the range. And then we can skip all of this. Now, I guess there's one issue because we still might have a range here at the end. So we still might need to, instead of, again, adding this to our subarray here, we'll have to calculate this range length and add it to our result. Okay, it's complicated, I know. And this is just current range instead of subarray range. Same thing here. Okay, let's see if this works. Okay, seems to work. So instead of storing these ranges, we'll just calculate our result as we find the ranges. Okay, it works. Still not giving us a great result. 14% for runtime, 7% for memory. So what else can we do in here? Well, let's see. We're keeping track of these ranges, and then we are calculating their scores later as we find the end of the range. But we don't really need to know the end of the range to start calculating the score. We know as soon as we get 1 0, that's 1. When we get 2 zeros, we add 2 more. When we get 3 zeros, we add 3 more. So as soon as we find a 0, we can actually start adding these ranges to our result. So let's do that. Instead of keeping this current range, let's get rid of our current range. We don't need this anymore. And we don't need this anymore. And we don't need this anymore. Whoa, this is going to clean up a ton of stuff. All right, and in fact, I don't think we even need our index here anymore. So we can eliminate the enumerate as well. Okay, what we do need though is to know how many zeros we've found so far. So we're not keeping the range with the index anymore, but we are keeping the count. So I'll call it 0 count. And we'll start it at 0. So now if we get a 0, then we'll increment our 0 count. And we can also add this immediately to our result. Now we're not just adding the 0 to our result, we're adding the 0 count. So again, if we find a single 0, then we'll add 1 to our result. If we find another 0, then we'll increment our count and we'll add 2 to our result. If we get a third 0, then we'll add 3 to our result. If we get something that's not a 0, then we need to reset. So our 0 count gets reset back to 0. And I think that's it. Let's see if that works. Seems to work. Let's see if that fixes our runtime. Let's see if we do better than our other algorithm. And that is a significant improvement. Now we're getting 89% for runtime and 78% for memory. And look how clean this code is compared to our original solution here. Look at this. So sometimes it takes going through that first approach, finding some of these basics, figuring out what does it really mean to have a range of zeros? What does it really mean when you run across a 0 in this list? How do we know what we add to our result when we do find that 0? So maybe you're able to figure this out without having to go through all these steps. But for me, it helps to sort of break this down into these steps where I find out one piece at a time until I get the realization that I can just do this simply by adding the number of zeros I've seen so far since I started seeing zeros. All right, let's see if there's anything else we can do here. I mean, we're in the 88%, which is pretty good. I'd love to get this to a 90%, but that might not be possible. Let's see here. Well, I could call this just count. Sometimes shortening our names helps. So if I just change this to count. All right. Let's see, and I need to change this one here. I'm not sure I can do much else other than change these. Yeah. Well, let's try that. And it does help. Now we're beating 96% for runtime and 30% for memory. Okay. That is probably just the computer that it's running on. I can't really imagine that changing from 0 count to count makes that much of a difference, but hey, I'll take it. All right, that's it for me. Hope you enjoyed this. Hope you had fun. Hope you learned something. Hope you can go out and write cleaner code.